All right, so I'll just get started. So my name is Mohanty. I'm the co-founder of AICrowd, which is a platform where we crowdsource artificial intelligence. And I personally have been thinking about the whole notion of crowdsourcing on via multiple angles for quite some time. And this is AICrowd, but I'll focus on a bunch of other problems that we have been working on, right? For example, I personally am a researcher. I'm still an active researcher in artificial intelligence. I work on teaching, ideally this should be a video, but teaching simulated skeletons how to walk, or how to play Minecraft using AI, more Minecraft. Then there's things like, can I look at satellite imagery and detect buildings in them? Or if you want to get adventurous, can I just generate satellite imagery which just look realistic enough? Or can we hack the current notion of AI models which detect if it's a panda or not by convincing them it's not a panda by adding noise that we cannot see as humans? Then you go to looking at images of food and try to figure out what food is in there, how much food is in there, so on and so forth. Or you want to really look at railway networks and why they're delayed and figure out how to schedule railways so that they do not get delayed. But across all of these, as a researcher, you are doing a bunch of things which are common, and those are also kind of common for a bunch of various disciplines of research. You always start by asking some questions. Then you imagine some solutions. In many cases, those imaginations come sequentially or in some chaotic order, but you only have the ability to kind of go and follow up all these imagination of solutions sequentially. And when you're training these models, you have dependencies on some data sets, or if you're doing something called as reinforcement learning, then you are making decisions dynamically. So you need simulation environments. And then you iterate on top of it, right? You imagine solutions, you train models, and you keep iterating until you get something that you're like, wow, this actually works. Then finally, you go into the deployment mode, where you take these models and you try and see how well it works on real world data so that you can create impact. Although in research, in many cases, the motivation may or may not be impact. It's could be all right, how far our research goes, or how many other research papers build up on our research, so on and so forth. But in this case, I would like to kind of focus on the importance of deployment and the whole potential of impact. At the same time, these are some key components that are already happening. At AICrowd, we kind of focus on many of these things in different capacities. For example, we are the ones who ask questions. We have a community of tens of thousands of users who come in, imagine solutions, and train models. They also go in and iterate on top of it. We just happen to have an objective way to say which solution is as good, better or worse than the other one. And then finally, in some of the cases, we take the best models that we actually receive and deploy them as APIs so that other people can start using them. Now, here the notion of compute is important across this, because here participants are using their own compute when they're imagining solutions, training models, and iterating on top of them. And when we are deploying models, we still kind of need compute because, well, when we keep getting a lot of those requests need to kind of run somewhere. So right now, we offload these compute requirements to the participants or the users of our platform who come in and compete to solve these problems for cash prizes, co-authorship on papers, so on and so forth. And in these cases, we cover the cost ourselves, where we pay for the compute that is needed to kind of deploy these models. Now, when we go back into this, back to this particular sequence of questions, for this talk, I would like to kind of focus on just three different aspects of it, right? Where we are trying to say is, can we actually even crowdsource the compute needs that are needed for this whole loop? Because here on AICrowd, we are able to crowdsource the notion of asking questions, imagining solutions, and also to some notion the iteration, which has dependency on compute. Now, if you talk about training models, now, when you're training models, you have, especially in context of deep neural networks, you have these large elaborate networks, and many of them have many components, subcomponents, so on and so forth. And recently, we had been exploring on, can we actually figure out how to train GPT-3 out in the open in a distributed way? Because GPT-3 is something that came out of OpenAI, and it created waves just because of how well it performed. But we still did not have any way to go ahead and manipulated in a way where we had the complete freedom. Okay, OpenAI exposed some APIs, but what then? We still did not have access to the weights and so on and so forth. But from OpenAI's point of view, it made sense. They stumble upon these weights and they stumble upon these ideas, so they stick to it. But given the way research in computer science and deep learning is done, many of these ideas are out there in the open. In many cases, it's about figuring out how to train these large networks out in the open. Except in most of the cases, when we're talking about training these large networks with billions, hundreds of billions of parameters, we are talking about tightly coupled clusters. These are these large clusters of nodes where all these compute nodes are in the same network. But here we are talking about loosely coupled networks where each node could be on a completely different geographical space. And we have overheads of how do we transfer all the weights between these two nodes? How do we ensure that the quota, the compute quota available for a node is something that is respected, so on and so forth. So there's many interesting engineering challenges that need to be solved, which before we can efficiently train these large models in a distributed way out in the open. And this is something we have been exploring, but I will revisit that at a later point of time if you ask me questions around that. Then the second notion is around deploying models. So coming back to this, so here the whole idea was, can we actually train a whole GPT-3 out in the open, right? This is crazy because only large Google, Facebook, OpenAI scale compute can actually train models like these because they are the only ones who have access to that large clusters. And we are asking, can we just use these large voluntary computing clusters to train these models and be ambitious enough to just roll out all the weights out in public so that anyone can benefit from the power of many of these advances which are being made. There are many engineering problems which need to be solved, and we are on it. The second approach is, can we actually look at problems where we can train models in isolation, but deploying those models is a headache. One example is some of the stuff we did around satellite imagery. We can train models which can work reliably well, respecting some of the biases that are already there in the training data set. They can work reliably well on looking at high resolution satellite imagery and detecting buildings of it. Now imagine a setup where every single day, this model, which has been trained on a bunch of GPUs, not really a large number of GPUs, but can actually be used to make inferences on satellite imagery that is collected every single day. And now in this example, we are still focusing on buildings because that's what for which we have training data. But even if you manage to go ahead and predict the building footprints across the whole of the globe every single day, then you are enriching our understanding of how human civilization is kind of spread out all over the world. And there's many applications of it, except right now we do not have one central stakeholder who would be willing to put in the compute for that. Now, in a case like this, this is actually moderately less difficult problem than the previous one that I mentioned, because in this case, we want one model to go on one node and then make predictions on a bunch of satellite imagery tiles that they receive. And here, figuring out how to just train these models well, and then make predictions and aggregate all these predictions and then feed them back to some other centralized resource. Let's say OpenStreetMaps is something that will create immediate value over and over again. And we can think of multiple such problems where this whole idea of deployed AI models will bring value. And this, I also personally think, is kind of a low-hanging fruit, because many of the engineering headaches that we have in loosely coupled networks is something that we do not have to actively deal with here. There are some constraints, of course, on what kind of models we can run and so on and so forth. But my most favorite one is around data sets. Now, in voluntary computing, data sets and running large set of simulations to kind of generate a bunch of data sets, something that has been explored. But in this case, I would particularly focus on this one particular kind of data sets, which are very dear to us, especially researchers in deep learning. Right, many of the things that we work on are around computer vision, where we have to look at these images and simply understand what's happening in there. In many cases, these are not just images, but also sequence of images or videos, and you have to figure out what's happening in there. In most of the cases, to be able to do anything meaningful in there, you need lots of training data, which is like, okay, in this image, there's this sheep here, there's this little dog in here, or there's this person here, there's sheep, there's dog. So we now are exceptionally confident that if you give us a large enough training data set, we can go ahead and train a pretty large, a pretty well-functioning model, which can reliably do predictions well. Except the problem is, collecting large data sets like this is expensive, because what you have to do is take a lot of pictures or videos, and someone needs to manually sit down and draw bounding boxes or draw these boundaries, so on and so forth. And in fact, most of the data sets that we work on are actually data sets that are collected in the same way. In this case, this is actually a data set from about 2012, which is still a more evolved version of this, is still kind of something many people use to kind of understand what's happening in a self-driving car, or so on and so forth. But this was something where someone drove around this little city, and then many people sat down together to draw bounding boxes around every car that they saw, so on and so forth. And that whole process is expensive. In fact, it's restrictively expensive irrespective of how much resources you have, because to be able to collect large enough data sets on which we can train meaningful models which can do these detections, suddenly we have to spend, as a researcher, spend a lot of our time on fundraising, this, that, and we never actually get our hands on the data. Or and by the time we get our hands on the data, in many cases, we pretty much have a theoretical, new theoretical advancement. So we are not able to kind of go ahead and try out many of these new ideas on new data sets right away. But the interesting bit is this apple. Now, this apple is interesting because it looks like a real apple, except it's not a real apple. It's a simulated apple. Now, it's a simulated apple in a 3D simulated environment where I have every little detail of its boundaries, so on and so forth. And in the simulated environment, I can place my camera anywhere I want, and I can draw these boundaries as I please, and I can change the environment it is, so on and so forth. And in a setup like that, you can actually create a really large number of data, which is really realistic. And if you go back to the same idea of how these previous data sets were collected, imagine the cost of acquiring these data sets. Here, someone is driving through the street in India, and many people are sitting down together and drawing these boundaries in an assistive way, one frame at a time. But by the time, again, as I said, we have all this data, we are really kind of introducing a latency in how we can actually see a new innovation in terms of ideas in action. So that's where we go back to simulated environments again. I grew up loving games, and I still love games. But that's where you see, wow, the way these games are improving, for example, GTA 3 and whatnot, and many of you probably have some experience with it, they become just more and more realistic every single day while still being real time for the players. And at the same time, they happen to have every little semantic detail about every little pixel that is in there. And which is unfortunately not the case in case of real world. For example, if I take a camera and I basically skateboard all around Geneva, my camera will not know where there is a person, where there's a bus, where there's a tram, or where there's a skyscraper, so on and so forth. But if in a simulated environment, I take a camera and I skateboard all around in this simulated environment, my camera will be an oracle at every point of time where it will know where everything is. Now, that whole idea is really powerful because you can use that to generate data sets to train these models. In fact, the availability of realistic data sets like this is the scarcity which many large corporations are kind of leveraging because they are large. So they have lots of data sets, lots of access to lots of data. And at the same time, the ability to also generate synthetic data sets like this, which will catalyze the progress in deep learning research and computer vision, so on and so forth, is also at a different scale altogether. And one of the key pictures I had is while looking at all the three approaches that we could actually take, my favorite one was this notion of figuring out how can we create data sets for which there is an excessive demand at this point, and there is not enough supply because we simply cannot find real data sets. But we still have the ability to create realistic data sets which are convincing enough and have enough information to allow researchers to collect arbitrarily any data that they want for setups like these. Of course, for every problem, you have to kind of figure out, does a simulator, realistic simulator like this exist or not? But these simulators in completely different domains are only maturing. And all we need is a centralized space where we can just throw these simulators with a well thought out and focused problem statement, and we create these data sets and we let it out there. And we won't just release the data sets, we will also release the state of the art models, which can come in and help push the state of art in our understanding for these problems. And in a setup like this, you could actually create data sets which are of the same scale as Tesla, except Tesla has to roll out real cars out in the world with all those risks to collect that data and also figure out how to annotate them in assisted ways or not so assisted ways. We can roll out these data sets by lots and lots of simulations out in there where we are collecting one frame at a time and its associated annotations. And the data set is available for any researcher to just jump in and start using it. And along with that, we would also want to release a bunch of baseline models, which hopefully eventually will become the go-to models for anyone who's trying to study a series of these problems. That was pretty much it. And I have a feeling I overshot my 10-minute window. Thank you so much. And I will open up the floor for questions, but I guess we have a panel discussion later. We can take them.
Yeah, no, we have time for a few questions. Hold on one second. Yes, so if anyone has any questions, if you could use the hand raise feature, it's in the bottom of your Zoom window. There's a reactions button, and one of them is hand raise. So if anybody wants to raise hands, please do. There's also an applause button there. And otherwise, we have a few talks on the topic of distributed AI, and we're going to follow these, as Mohanty mentioned, with panel discussion. And so we'll get a little bit more interactive engagement, at least among the people giving talks in a few minutes. So if no questions, then I'll comment that I'm extremely fascinated by this idea that at the end of the day, your proposal is to use computers to train the computers, and it makes me realize that in actual real intelligence, we actually probably don't learn from reality, but we learn from our representations, and this is extremely interesting. So anyhow. I look forward to talking more in the panel discussion. And I think next up we have